Previously, we looked at differential equations, but we looked at a very basic kind where they were in this form. dy dx equals some function. We're going to continue on with differential equations, but we're going to look at some slightly more complex looking differential equations. So just in general, a differential equation is an equation involving the derivative of some function and often the function itself. So we're going to consider this one, dy dt, so the derivative with respect to t of y equals 100 minus y itself. And we want to know, is this a solution? Well, this is y. And so what we're saying is if you do the derivative of y, so if you do the derivative d dt of 100 plus e to the negative t, you should get 100 minus the actual function itself. Y is 100 plus e to the negative t. So we want to check to indeed see that that's true. Well, the derivative of 100 would be 0. And then using the chain rule, you have an inside function, negative t. The derivative of e to the negative t would actually be negative e to the negative t. Then on this side, 100 minus 100 also gives you 0. And then distributing that negative sign, minus e to the negative t. So we get negative e to the negative t equals negative e to the negative t. Indeed, those two things are equal because they're the same. So this is a solution. This is another form of a differential equation, but here we're actually looking at the second derivative. So this is to verify that y equals sine of 2t is a solution to the second derivative of y plus 4y equals 0. So let's see. We want to start out by doing the two derivatives. So the second derivative of the second derivative of y. So we're doing the second derivative of sine of 2t. And then plus 4 times sine of 2t should give us 0. So let's see if that indeed is the case. So let's start just by doing the first derivative. So we'd still have another derivative left to do of sine of 2t. So we've got an inside function there. The derivative of the inside function is 2. The derivative of the sine is cosine 2t plus, and we still got our 4 sine of 2t, and that should give us 0. Well, if we do the derivative of 2 cosine 2t, remember the derivative of cosine is negative sine, and we have an inside function, you would have 2 times negative 2 sine 2t plus 4 sine of 2t equals 0. 2 times negative 2 would be negative 4 sine of 2t plus 4 sine of 2t should equal 0. If we add those two things together, we get 0 equals 0, and that is indeed a solution. Alright, here we're just going to look at some slightly different formatting. We're using that different notation. We're using the Newton notation of y prime. So is y equals x cubed a solution to x times y prime minus 3 times y equals 0. So if I fill this in, I'd have x times the derivative y prime. The derivative of x cubed is 3x squared minus 3 times y is x cubed, should equal 0. So that's 3x cubed minus 3x cubed, and we get 0 equals 0. So again, this 3x squared, just so we're clear, that's my y prime. Alright, one last example. Let's determine if y equals x to the 4th plus 3 is a solution to this differential equation. So if we fill this differential equation in, you have x times d dx of x to the fourth plus 3 should give us 4 times x to the fourth plus 3. If we find that differential equation, we'll get x times the derivative of x to the fourth plus 3 would just be 4x cubed, should equal 4x to the fourth plus 12. We get 4x to the fourth equals 4x to the fourth plus 12. Those things are not equal. This is not a solution.